Alright, oops. Is this the beginning? Okay, hello. Here we are. Here's the beginning. 23D.1, and this has sections D1 through D3. It's too long for one day, but I'm not too sure. It might be we'll see. We'll try it for 2 days and see how that goes. And anyway, we're going to be looking at the binomial distribution. And these binomial experiments that we've been working with, by the way, they're called binomial because there's two possible results, either a success or a failure. So we see that here in item number 1. And we will be repeating the experiment in a number of independent trials. That way, the probability of success P will be the same for every trial. And then obviously, if the probability of the failure would be 1 minus P, and we've been working with that already. And as well, we also know that the random variable X is the total number of successes in N trials. So these 5 things we've been working with already, but it's just good to remind ourselves of these things. What we're going to do now is look at a binomial probability distribution. And in order to do that, we're going to consider a spinner that has 3 blue edges and 1 white edge. So I'm going to draw that. I guess I'll draw it the way that I think the book does with these, because they say edges. So we'll make 3 of these, whoa, that's not what I wanted. 3 of these blue, and then 1 of them is white. And we're going to say that getting a blue is a success and a white is a failure. So because blue is the success, then P will be the probability of a success, so therefore P is the probability of getting a blue. And in that case, we can look at the spinner and see that that's going to be 3/4. So therefore, the probability of a failure is 1/4, obviously. Consider twirling the spinner 3 times. Okay, so that's our N. N is 3. Those are important numbers to identify. And we're going to show the probability distribution. And in order to do this, we're going to kind of investigate it and discover it. And we're going, so because we're spinning 3 times, I'm going to use a tree diagram to look at this. So the first spin, second spin, and third spin. On the first spin, we could either get a blue, or I'll say a not blue, the complement, in other words, a white. Second spin, we could get a blue or a non-blue. You can use white there instead if you prefer. Blue, non-blue, and so on. And we've done lots of tree diagrams. So we'll throw our probabilities on there. Probability of a blue is 3/4, 1/4. There they all are. I should have drawn that smaller because now I need space for my probability distribution. You know what I'm going to do? I'm going to shrink it. Let's see if I can do that from up here. Will it collect it all? Yeah. Let's see this one. Oh, it doesn't really shrink the whole thing. It's not what I wanted, really. I wonder if I can bring... Oh, I could have done that. Tell you what I'm going to do. I'm going to undo and undo. Go back to where I was. Okay. Sorry to take up your time on this, but I do need that space. Oh, that's okay. We'll shrink the whole thing. So what I'm going to do is get smarter about this and do that. And then move it. Whoops. Move it over here. Oh, oopsie. You need to move over there too, don't you? Maybe I'll just fix it at this point. I'm sorry to take up your time. This was the first, second, third, blue, non-blue. Okay, there's all the information. So now to get the probability distribution, we have to look at our x's. So the x's are going to be the number of blues. So we could have 0 blues, 1 blue, 2 blue, or 3 blues. And if we have 0 blues, that's going to happen down here on this branch. So that's 1/4 to the 3rd power. So here I'm putting in the probabilities. And then 1 blue would be, let's see, that would be, I'll highlight those just for fun. It's always a little harder to see them from up here. There's 1 blue. And here's a blue. And here's 1 blue. So those 3 branches are the 1 blues. So I see that that's 3/4 times 1/4 to the 2nd plus, because we have to add each branch. This one's also 3/4 times 1/4 to the 2nd. And the last one, if you look at that branch, it's also 3/4 times 1/4 to the 2nd. Which means there are 3 of those, so I can say that's 3 times 3/4 times 1/4 to the 2nd. And now we're going to do the ones that have 2 blues. So I will do that in a different color. Let's do, we'll highlight again, let's do this grayish color. So 2 blues, that would be this branch, and this branch. And on this one I'm seeing I have 3/4 squared times 1/4. And the next branch is also 3/4 squared times 1/4. You can probably see where this is going, right? And the last one's going to be the same, right? 1/4, 3/4, 3/4. So that's 3/4 squared times 1/4 again. And so we have 3 of those, so we can combine like terms, so to speak. Oops, that was 3 squared. I was looking up there. That was 3/4 squared times 1/4. And then finally, 3 blues is the top one. 3/4 times 3/4 times 3/4. So 3/4 to the 3rd. Now if you look at these 4 things, hopefully that looks familiar to you. And you probably have a pretty good indication since it says binomial distribution. And doesn't this look like the binomial expansions that we did earlier? Especially if I write it out like this. 1/4 to the 3rd plus, you know what I'm going to do, because I started with 1/4, I'm going to put the 1/4 to the square, I'm going to put 3, and I'm going to do the 1/4 squared to the times 3/4. I'm going to reorder it a little bit so that it matches the pattern of the binomial expansions that we did earlier. There. And even look at the coefficients, 1, 3, 3, 1. So that's from Pascal's triangle. And you can also think of this as n. So what's the n value? Well, n is 3. So 3 choose, this could be 3 choose 0. And I'm going to have to think for a sec here. So I have to think about the r. This would be 3 choose 1. This is 3 choose 1. And this 1 matches this one here, because this is to the power 1. So this is like your r value right here. That's the r. And this would be 1 minus r. Or no, n minus r. Sorry about that. That would be n minus r. And then here this would also, well, this would be 3 choose 2. Because then that would be the r, and that would be the r, and this is the n minus r. Because n is 3, so 3 minus 2 is 1. And then this is 3 choose 3, which is, 3 choose 3 is 1. And now that should look familiar. That's the binomial expansions that we did earlier in previous chapter. So this is the probability distribution. When it asks you to find the or to show the probability distribution, from now on, instead of making this whole tree diagram, you can go ahead and just stretch it out like this using the binomial expansion that you're familiar with. In fact, on this next slide, what I'll do is I'll give you, let's write down the general term. In fact, maybe I'll do it here so we can look at this. So the general term, well, I'll tell you what, just to save time, because for me to sit here and look at it and think about it, it's going to take a minute, and I'll just save your time. I've already got it written down, and I'll just write it down. In fact, what I'm doing, I'm skipping ahead a little bit. Let's do that. It's nice to save a little time. It's actually this slide here, the binomial probability distribution function. And there's a bit of writing, so let's do this. Consider a binomial experiment. And this is straight out of the book, I'll admit it. For which P is the probability of a success. And then 1 minus P would be the probability of a failure. Okay, now, if there are n independent trials, so again, there's that emphasis on independent, because that's important. Then, and here's the important thing that you need to make sure you get. Well, all of this is important, but here's the formula. The probability of x equals r is, and choose r, I was talking about that on that previous slide, p to the r and 1 minus p to the n minus r. And I was going to look, if you look in your formula sheet, on topic 5, this is 5.8 is where you will find this in your formula sheet. And that's exactly how it's written. And then r goes from 0, 1, 2, all the way up to n. And by the way, this whole thing also has a name. It's x is distributed as, that's how that's read, b of np. So that's how you read that little tilde. That's a tilde. X is distributed as the probability, or the binomial distribution n comma p. So it's kind of like the general, it's basically the general term right there. Okay, and this p, yeah, this is the binomial probability distribution function, this part right here. So where it says the binomial probability distribution function, that's this right here that I underlined. And not only that, it looks like I've also got the expected value written here. So also, the expected or mean, remember the expected value is the mean, and mean is mu, is, and it's also expected value like I was just saying, and that, as we already know, is n times p. Also, oh, we don't have to write that again. That was the next point I was going to write down, was this right here. So it's already there. All right, good enough. This is a really important slide here because it summarizes that entire slide previous with the whole tree diagram and the binomial distribution. Now I can jump back to example 8. And this one, you know, is basically, this is just your binomial expansion that we did in the previous chapter. So I'm just going to go ahead and do that. I think I'll go ahead and use the formula, or you could use Pascal's triangle to get your coefficients. I'll use the formula though just to kind of help with that. So the first one's going to be 5, choose 0. And then, here, let me write that formula down again. And choose r. And then the, sorry. I have to admit, I'm kind of learning this along with you, so I don't have these memorized super well. The probability of the success is going to be raised to the r. That's important to remember. And then the probability of the failure will be the one that's raised to the n minus r. So we're going to have 5 choose R, so R is 0. So that means the probability of a success, that's 9/10, that's going to be raised to the R, which is going to be, the first one is 5. And then on that first term, we don't have the term 1/10 because that's raised to the 0. And then we have 5 choose 1. And then 9/10 is going to be raised to the 4th, and then 1/10 will just be raised to the 1. 5 choose 2. 9/10 will go down a power, and the 1/10 will go up a power. And then 5 choose 3. 9/10 will go up down a power rather. 1/10 is going up a power. And we need a total of 6 terms because n is 5. So I've got 1, 2, 3. I've got 4 terms so far. And then 5 choose 4. 9/10, that's going to go stay there. 1/10 will be to the 4th. And then our final term is 5 choose 5. 9/10. Oops, 9/10 isn't there anymore because it's to the 0 power, so I just don't even bother writing it. And then 1/10 is to the 5th power. And then you can go back and write down what 5 choose 0, 5 choose 1, and so on, what those are. Or you could have just used Pascal's triangle and used them right away. So it's really 1. You know what I'm going to do? Because I have it. I'm going to do the highlighter. So this is 1. 5 choose 1 is 5. 5 choose 2, if you work that, it's 10. And this one's also 10. This one is 5 because of symmetry, and this is 1. Good enough. So when you expand it, just leave it like that. And then we can answer the next question. An archer has a 90% chance of hitting a target with each arrow. If 5 arrows are fired, so right away that's your n. Your n is 5. Determine the chance of hitting the target. So let's identify what x is. X is the number of times hitting a target. Does it say that? Yeah, right here. Chance of hitting a target is, so x is the number of times you hit the target. And P is the probability of a success, so that's the probability of x, and that's 90% because I give that to you, so that's 0.9. I think it's helpful to identify your variables ahead of time. And now, because we use that form, we know that formula, if we're going to hit twice, then that's the x. So x is 2 in this case. And I'm going to go back and use my general term that I had before there. So that was n choose r. P is raised to the r. 1 minus p is raised to the n minus r. So you can remember that. Of course, you don't have to memorize that because this formula is given to you. And then I have to think about this for a sec. I do believe the r is the 2. Yes, the reason I know that r is 2 is because x is the number, it has to do with successes, and p is the probability of a success. So I know that r is 2. So then I can just plug stuff in. So I've got 5 choose 2, p is 0.9, r is 2, and then 1 minus p, of course, is 0.1, and then 5 minus 2 is 3. And if you calculate that all out, I'll save time and just tell you what the answer is. So it's a pretty small probability of hitting the target twice only. Now we're going to do at most 3 times. So what does that mean? Well, that means you can't go over 3, but you can be 3. So x could be 0, 1, 2, or 3. And the good thing about this is actually we can use some of our work from that previous expansion. The reason being, on the previous expansion, see, they kind of set us up for this to help us out. This 9/10, of course, is 0.9. And, of course, obviously this is 0.1. So we just have to figure out which of these terms will be when x is 0, 1, 2, or 3, right? So that means when the x's are the r's, and the r's are the ones that are the powers of the success, which is the 9/10. So that's going to be, I'll underline them in yellow. When x is 0 is this one. When x is 1, because the x's are the r's, and the r's are the powers of the successful probability right here. So that's when r is 1. This is when r is 2. And this is when r is 3. So we need to find those values and add them up, and we will get the answer. And if you do that, this one is 0.0729. This one we just did earlier, because r was 2. And this one is 0.00045, and this one has 4 zeros. I worked these out ahead of time to save time. And when you add all those up, you will get 0.08146, or if you round to 3 sig figs, 1.5. So that's a probability you will hit at most 3 times. That's not a very good probability either, is it? Yeah, so the main things to remember are that the r is the x, because the x has to do with the successful ones, and the successful ones' probability is p, because these x's are the successful outcomes. We did that. Okay, example 9. So I'm going to switch back to a better color. You certainly don't want me to use yellow this whole time, right? 72% of union members are in favor of a certain change to their conditions. A random sample of 5 members is taken. So right away I see that and I think n is 5. I like to identify those things right away. And we're looking at letter A, find the probability that 3 members are in favor of the change. So x is the number in favor of the change. I'll use the IB spelling. That means p is the probability that the person is in favor, so that is 0.72. So we've identified n and p. And if we want to do 3 members, then that means that x is 3. Or in other words, then in the little formula, then r is 3. So that means I can do, that formula again is n choose r. I always have to write it down. P is to the r. I didn't really need parentheses. 1 minus p is to the n minus r. So n is 5. Choose 3. P is 0.72 to the third. And then that's 0.28, 1 minus p. And then 5 minus 3 is 2. When you put that into a calculator, you should get 0.293. Oh, and guess what? I have a little note here to myself. There's actually a way to do this on the calculator. Other than just plugging this straight in like that, there's a command that will do this. And I need to bring up my calculator again. Well, what you do is, so you see there's this distribution. I can't see it on here. It's a function we don't use very often. It's under vars, so it's second vars. And if you arrow down, you get this. Option 10, binomial probability distribution function. So that's what the PDF stands for, probability distribution function. Because if you go down one more, there's a CDF also. I honestly don't know what that stands for. So we want option 10. So that's distribution 10 is where you go. Choose 10. Binomial, I can't remember what it all said. It's basically PDF though. Probability distribution function. And then what you do is you have to remember NPR. So you put in NP and R. Thankfully, that's easy to remember. So we said N is 5, P is 0.72, and R is 3. Oops, now why did it put a 6 in? I do not know. And there it is, 0.9293, just like we had said earlier. So that's pretty handy. Oh, the other thing I learned about this, and I don't know how it is with the 84s, since I'll be honest with you, this is new stuff to me. But according to our book, it says that you can also do, you know how you can do a range like if P is less than or equal to some number? Here, let me check this out. I'm going to make sure I give you correct information. Here, I'll just read it out of the book, and you guys can probably check it out yourselves too if you have your book. On the bottom of page 621, it talks about this. It says, some calculator models, such as the TI-84 Plus, only allow you to calculate x is less than or equal to r. Whoops, okay. So that means if you need to find x is greater than or equal to r, then if you need to do this, then what you can do instead is use the complement. And so the complement is 1 minus the so let's see, I'll just give you kind of an example. So say those were your x's, and you wanted to know where x is greater than or equal to 4, let's say. Well, all the numbers greater than or equal to 4 are these, 4 and 5. And your calculator won't let you find that, but it will let you find, you could do the x's that are less than or equal to 3. So notice how you have to do x is less than or equal to r minus 1, because that would be the complement. So you might want to remember this. I suppose I should probably use the correct notation here. Yeah, this is probability. I'm going to make sure I'm writing it correctly. Okay, so that looks good. So remember this if you want to use your calculator, because apparently the calculators will only do x is less than or equal to some r value. Now we can move on. So we need to do, I've got all this stuff written down here, and now I need to do letter B. The probability that at least 3 members are in favor. So I'm going to have to erase this, or at least part of it. Let's do this. So that's the probability. If at least 3, that means 3 or more, so greater than or equal to 3. And guess what? That means we have to use, if we want to use our calculator, which we certainly do because we don't want to have to do that by hand, do we? So that means we have to use this rule here. That means we need to we have to do 1 minus the probability that x is less than or equal to 3 minus 1, or 2. Now let's put that in the calculator. Second vars. I don't think you could skip down to 10. Maybe you can. I have not had good success doing that, trying it. Okay, and it's NPR. Oh, by the way, so I'm actually finding, oh, less than. How did that work? Because up here it equaled. I did this earlier too, wouldn't you know it? Now I'm beginning to doubt myself a little bit. Because if you do that, it's going to be equal. I'm not too sure how I did this. Tell you what I'm going to do. I'm going to stop the video, because now is a good place to stop. I'm going to investigate this just a little bit more and make sure I'm doing it correctly. And then I will get back to you and we'll start the second half. So, to be continued shortly.